In this video, we about to talk about some loop statements, and I'm testing out this Insta 360 webcam. Stand by. This video is about to start. This is the Savage Scientist Ed right here, and I'm writing code in a police car. What up, folks? This is the Savage Scientist Ed, and you already know who this is because you watched the intro. So, this video is sponsored by my subscribers, not Insta 360 or the company behind it. And now that we got that out the way, let's turn the lights up and see what happened. This is high-powered light mode. And most likely, this is how I'm going to get the sharpest image. But you know this is the Savage, so I like to keep things dark here in the state of Swampland. And this is what I'm going to be looking like most of the time I use this camera. In this little small circle, bottom of your screen, not bothering you while you code, because you need as much screen real estate while you're doing some coding, right? So here go the topics for this video. Jump to whatever you want to get to or whatever you want to watch. You know I don't want to waste your time keep repeating this crap, so you already know the ordeal here. Jump to whatever you want to see, and now it's time for us to start talking about these loops. So we're going to start off with the if loop, and we're going to talk about the while. And then we're going to talk about our for loop. And last, the switch statement. Here is one way to increase your chance of getting that $100,000 a year FANG job. Do not refer to if, while, and for statements as loops. If you use the terminology control flow statements, just like lawyers have their own terminology, here in the programming world, we have our own terminology too. So it's time to start using it. So for the rest of this video, I'll refer to loops as control flow statement. And we're going to start by declaring a variable called X here. And this box represents the control flow statement. And this is the condition that holds the control flow statement. And this is the logic that will be processed while the control flow statement is true. And within these curly braces is the body of our control flow statement. And remember, control flow statements are our basic loops. If, while, for, switch, you know, the ones we talked about earlier. And this is some condition. So we could say something like, while X is greater than 5. So we're going to start with our if statement. So if X is greater than 5, we're going to process these two lines. And we're going to do that one time. And our program will continue on the outside of this curly bracket. Or if our condition X greater than 5 is false. So let's say we get to our if statement. So let's say X equals -3. When we get to this line, our program execution is going to jump here. Because this is only this, that means that this became false. So that's the beauty of our if statement. So now let's take a look at some more statements here. So let's look at our while statement. So we'll just say while X is greater than 5. So right here we're going to say X is 2. So while X is greater than 2, we're going to have a continuous loop that will not stop unless we have some value in here that manipulates the value of X, something like X plus plus. So with each iteration through this list or each loop, we're going to repeat it. So the first loop is going to say X is 3. Next time we go through it, X is going to be 4. The next loop, X equals 5. And next loop, X equals 6. Once X is 6, we're going to break out of our loop and continue processing right here. And that's the basics of our while loop. And now it's time for us to take a look at our for loop. Our for loop is almost follow the same logic as our while loop. So let's say X just happened to be 6. In our for loop, the bounding condition will dictate how many times we're going to loop through this code. For example, we're going through this loop 6 times. And with each loop, our value x is going to increase. So once it increases to 7, we're going to exit out of our for loop and continue processing. And that's 6 loops. And that's it. And normally these 2 lines of code could do whatever we want. We could print stuff to the screen. We could change the way our loop behaves by having it increment over 2x instead of just incrementing x by 1. So now it's time for us to take a look at our switch statement. So let's say we're looking at a value x. So this is like selection. So we're going to say if and our switch statement basically combines the if statement. So if x equals 3, we're going to process something here. And now, if x is 4, we're going to process these lines of code that corresponds with the statement x equals 4. So the switch statement combines the power of the if statement nested. So normally in our switch statement, we would have a variable, or we're going to have a condition that breaks out of our switch statement. In that case, our program execution will continue on the outside of the bracket. Now it's time for us to start dev C++. And we're going to start a new project. Console window application here. And we're going to name this control flow. Or we could just say CTRLFLW. And we won't be using command line arguments, so we're going to get rid of that. And we're going to put our using namespace std right here. So that means we're using our standard template. So we're going to declare 2 values, int x and int y. So we're about to redo our if statement. So if you haven't seen the last video on Boolean operations, we're about to cover a little bit of that right now. So let's create a basic program. So we're about to ask the user for a number. Enter a number greater than 5. And now it's time for us to place that number in our variable with the CIN function. That's it. So now it's time for us to use our if statement. If x is greater than 5, we're going to print out cool, you entered, and we're going to print out our value x, which is than 5. So let's get ready to run this thing. So in our case here, we're going to enter 6. And that's what we got. See? We entered 6, and that's greater than 5. So what happened here is the user entered 6, and since 6 is greater than 5, we were able to print this line. So let's see what's going to happen if we enter a negative number. What you think is going to happen when you enter negative 12? That's right. We will not get anything printed to our screen. So now, how could we fix this? We want to go back up here if you enter a value that's greater than 5. So let's do this. We're about to use the else statement. Else go to. So we're going to print two things. Cout you entered a value less than 5. And now we're gonna say go to start. And now we're gonna put start right here. And it is terrible practice to use go-to statements, but this is a demonstration on why it's good to use all these loops. So let's say we entered 3. You enter the value less than 5. So now we're asking for a number again. So we're going to say 4, 5, 56. So now, cool, you enter the value 56, which is greater than 5. Now we can leave our program. So all the other values we just entered did not work, including 5. So 1, 2, so any value less than 5, including 5, will not work. So if we want to include 5, we do it like this. So this is 5 including 5 itself. So if I run this again now, we can enter 5. And there it is. Cool, you entered 5, which is greater than 5, which is greater. This should also read, which is greater than or equals 5. So that's basically how this loop works, how our if statement works. So if we look at go-to statements, we have to pair that with our label. Our label is on line 9. And in C++, the proper way to create a label is to end it with a colon. And if we start adding go-to statements or adding labels, let's say we have a label right here called label 2, label 1 up here, and then we start referencing these labels. So let's say right here we have X going to L2, and we have this, instead of this return, we're going to L1. And as you start adding more references, it starts to really look like spaghetti. And that's why they call it spaghetti code. I don't know how to spell spaghetti, but let me look it up. Spaghetti. And this is bad practice. So don't use go-to statements in your code. So now it's time for us to clean that up a little bit using other control flow statements. So we're about to put our while keyword to use and make a while loop. So we're about to make a counter. counter counter. So let's get rid of the bad stuff here. And we're going to get rid of this because else doesn't work with while. So let's just put our, so this is one of our new loops here. So we're about to reference it. While. So we're going to change this to while. So while X is greater than 0, we are going to count down. And so now we're going to change our writing here. So countdown. From X value. So we're going to name it countdown, and now enter a start for countdown. And that's our CIN statement. And now we're about to just change this to countdown. So can you spot the bounding condition on our while statement? Exactly. That is X being greater than 0. So we know the direction that we're going to start counting down. And we're going to get rid of this 5 right here. And we're printing X. And we want a space in between it. So we're going to just put a space there. That's our space going. And now let's decrement X. X equals X minus 1. We could also have said X minus minus. That does the same thing. So now it's time for us to demonstrate our while loop. Countdown. Enter a value for our countdown. I would like countdown on its own line, so let's post that on a new line there. There we go. There it is. So we're going to start with 85. And there it is. So we just start our countdown, and it's a very fast countdown, instantaneously. Count it down from 85 to 1. And that's it. So how did this work? We just created a loop that started at 85. And it looped 85 times until it got to 0. So once our condition became false by X being less than 0, and this is where that Boolean stuff comes in, our processing continued to exit. And that's it. That is our while loop. And this is a very powerful loop because this is how we're going to return back and fix our calculator program. We could do that with a while loop, or we could do it with our upcoming switch statements. So now let's continue with one of the most powerful control statements in the C++ language. We're about to talk about the for loop. Our for loop has 3 parts that's separated by semicolons. And this is the proper syntax in C++. So you might notice right here, the first thing is X. This is our variable. This variable will be within the scope of the body of our for loop. And we have our condition. And our condition here is as long as X is greater than 0, we are going to do this action. Our action here is increment X. And if you notice, this is not the behavior we want. So we actually want to decrement X. So this is a remnant from our previous example. So let's change it in the code. When we were using our while statement, and let's put the while statement up here. So as you can see in our while statement, that this line was necessary. But we also have the same line here. So for each of these, for each loop, what we're going to do is decrement X until X is less than 0. So like when X is 0 or -1, we're going to return to line 17 and continue processing right here. So this behavior will actually subtract by 2 because we're going to print this line and then we're going to decrement again on line 15. So check this out. Now, this might not be the behavior you want, which is definitely not the behavior I want. So you're going to see how we're going to fix this. So let's run this code. So we're going to enter a start value of 60. And as you notice, our loop is, we are decreasing by 2 each time. So starting off with 60, 58, all the way down to our lower value. We're about to run this again, and this time we're going to get rid of this line, which this line is a remnant from when we used our while loop. So now let's run this again, save and run. And let's enter 60 again. And now you can see we are decrementing by 1. 24, 23, 22, 21, all the way down to 1. And you can see it's starting off at 60. This is the behavior we want. So ain't nothing stopping us from doing that right here by saying x equal x minus 2. So we could take care of all our sophisticated looping right here by assigning x to x equals x minus 2. So let's run this and see what happens. So right here, we're going to say x is 60. And hopefully we're going to start decreasing by 2. And that's exactly what we have. So what is stopping us from saying x minus 20? X equal x minus 20. And we're going to enter 60 here. And there it is, 60, 40, 20. So this is our action that happens for each time we loop through this thing until we get to 0. And that's our for statement in a nutshell. So I think it's time for us to move to the big one here, our switch statement. So now let's retype our poor man's calculator. They will have int xy remainder. I don't even remember the rest of it. So now we're about to use our switch statement. And that's it. So our switch statement basically takes a value here. So this could be anything. And outside of that, we're going to say poor man's calculator. And now we want to enter a value. We're going to say enter first value. And x will hold our first value. This is our first. And y will hold our second value. So now we got our 2 variables out the way. And now for our menu system. So we're about to print many options here. So first one is add subtract multiply divide. And we're going to just do modulus as a separate operation too. And since we added, we about to say this option is going to be change numbers. And the last option will be exit program. So this looks familiar, doesn't it? So we're gonna say 1, 2, 3, 4, 5, 6, and 7. And now we're about to get our choice. And we're gonna work on our switch statement now. So let's put our curly braces here. So first thing we're gonna do is we're gonna use the keyword case. So in this case, we're gonna be using this is gonna match the data type of choice. Since choice is an integer value, our cases has to be integer. So we can't have something like case equals the letter D, character D. That won't work. So in this instance, we're going to say case 1. And if case 1, in the case of this answer, we're going to say COUT, and we're going to print X plus Y. And we could say something like result equals of, and we could actually print X and right here we're going to put our plus Y, and this is going to be our equal signs. And there it is. The result of X plus Y equals on case 1. And we're going to finish up the rest of this. So let's see what happens when we try to compile this thing. Poor man's calculator. Enter the first number, 4. Second number, 5. So let's add. And there it is. 4 plus 5 is 9. So we're about to implement the rest of this. So we already know that we got case 1. Let's do case 2. I guess we could finish up with case 3. And notice these are semicolons. So the case statement uses semicolons. And you know what that's kind of reminiscent of, right? Yes. If you thought about it, this is just like using Goto statements in labels. And notice this isn't a video on the details of how to use the switch statement, because there are a lot of things I'm leaving out, like the default and all that other stuff. But we'll get to that later. So let's see. So in case 2, what was our cases here? Let's go back up here. Add, subtract. So we didn't change numbers until we got to 6. Add, subtract. And add, subtract, multiply. Divide. And modulus. And now we're gonna copy this again. Because when we get to case 6, we want all this to happen. Now you get to see it. Now you have a chance to see a complex case that spans more than one line. And when you want to span more than one line, we use these curly braces. All right, so now it's time for us to give this thing a quick run. Poor man's calculator. Enter a number, we're going to say 98. Second number, 66. So now let's select add. That's going to be our first choice here. And take a look at the results. We have our add function, subtract. We have all the functions as if it doesn't matter what you select out of add, multiply, whatever. So that's the behavior you get whenever we don't use a break statement in our case. So that's it. So let's fix that now. So the problem we have here is after each case statement, we do not have a break statement. So let's put our break statements in. And what the break statement does is it's going to break out of this switch clause and it's going to continue down to here on the outside of our switch statement. So let's put our break statement in case 2. And I just copy the break keyword so I could quickly do this. So in case 7, this is not necessary. Now case 7, and we could just say something like exiting program. If I can learn how to spell today. So now let's give our program a run, save run with F11, and let's see what happens now. Enter our first value, 745, like a BMW, 441. Now let's add them. And now we have the desired results. But we still can't go back into our program. I want to see what happens whenever so now let's run it with option 6 to change the numbers. So we're going to put in 987, 74, and let's change our numbers. Option 6. And we're able to do that, 84, 332. So that's the behavior we get. So now it's time for us to make it so this thing works in a real loop so we could change numbers and play with different operations. So complex statement. Let's capitalize that. So what we're about to do is we are about to take our switch statement and encapsulate it within a while statement. I highlighted all the code from our switch statement and shifted it over one tab. And this is for our while statement here. And our condition here is going to be while choice is not equal to 7. And I could even put a comment here, start while. And I like how whenever you're using dev C++, how our brackets are lined up. And you can see that something is missing right here. That is a real good feature of using this code editor. So now we have our while statement to trap our switch clause and make it so we could keep repeating. So let's run it now and see if we get our desired behavior. I want you to pause the video and predict what's going to happen when we try to run these results. Enter our first number, 745 and 885. So let's add those numbers. So that's not what we're looking for, right? We about to fix it so our results won't be in this continuous loop. So let's fix it. We're going to always set our case to 6 when we're going on the outside of our while statement. So right here, I'm about to set our choice to 6. And that's going to make it so you are forced to make a new choice. And that's the same thing as saying a default. So check this out. Our first number, 745 again, 85. Keep doing the same numbers. So now, that's it. So now, you see we asking for a value again. And now, that's it. So we just fixed the big problem with our poor man's calculator. When we enter a first and second value, and we select an operation like one add, now we're gonna get one result, and we will jump to line 59. Our while loop will handle our break statement after choosing to add X and Y. And last, we're gonna jump to case 6 in our switch statement. And notice there's no way to handle user selecting a different operation. So that's why we stuck in an infinite loop where it's just asking us for 2 numbers all the time. And we're about to fix that right now. So to fix our infinite loop, we're going to get rid of our choice equals 6 at the end of our while statement. And we're moving that to each of the case elements in our switch statement. So in this case, whenever the user selects adding, which is case 1, it's going to default to choice number 6. And we're going to do that for our subtract, multiply, divide, add, all the rest of them. And you notice in case 6, that's the only place where we're going to be setting our choice, and then that's going to dictate our case. And if you select 7, we're going to exit the program. And now let's see what happened when we run it. Enter first value, 74. And we're going to, all right, so we got mod working here. And we're going to do 1, add. So and our program exited. We're gonna run this one more time because I really think that this is something you should be proud of. You created a damn good shitty garbage calculator. We're gonna enter the number 985, second value 745, like a BMW, and we're gonna divide it. We're gonna select number 4. And there it is, our results. And now it's going back into the same loop to enter new numbers. So we're going to say 858, second number 7441, and we want to add them, right? So we're going to select 1 for add. And there it is. Our values were 858, 7441. And you can see our values being printed here. And let's exit our program after running it one more time. Let's see which one we didn't do yet. I guess we did all of them. And let's just exit program. And there it is. And you notice when we exit, we don't even see this line that says exiting program. Soon, whenever our case is 7, it becomes 7 before this line is executed. So therefore, we don't even need this line. And we don't need this break statement either, but we could leave it here just for simplicity. So this is it. This is all 74 lines of code to make our calculator work. And one more thing, we don't need this either. What we could do is just set choice equals 6 soon whenever we start our program. And we still gonna have to, oh, here it is right there. So soon we start our program, we could set our choice to 6. When you set your choice to 6, it automatically starts in the mode to enter numbers with the menu. So that is what we consider optimization, when you try to get rid of unnecessary redundant code, or that's refactoring your code. So, okay, so now let me turn the lights on in here, because I'm still experimenting with this Insta 360. So there we go. We got a little light here. All right, and I actually got the Insta 360 sitting on top of my C920. And let me put it back on here. You should see how this thing is rigged up. And I got junk all over the place. So, got a 4K capture card here that I'm going to be experimenting with. So, I just took about 40 minutes of your time with this video. So if there's something that you might need to brush up on, go back through the video, because this was a long one, but it's very important to understand these loops as we progress into day 10 functions. So this is the Savage Scientist Ed, Governor of the State of Swampland. Till I make my next video, day 10, peace out.